Okay, in this video, we're going to talk a little bit more about graphing, graphing graphs, like that's graphing calculator. Okay, so you've already went over extrema. So extrema just means maximums and minimums. So in this video, we're going to talk about that some more, but we're also going to talk about where functions increase, in other words, go up, and where they decrease, in other words, go down. All right, it's going to have something to do with the derivatives. All right, I'm going to pull up my PowerPoint, hopefully. Okay. We're going to talk our way through it. Okay. So we're going to talk about where these graphs increase and where these graphs decrease. And we're also going to get relative maximums and minimums off of these. All right. So that'll assist us when we're trying to graph something without our graphing calculators. So you know some general shapes. You know that cubics are usually S-type curves like y equals x cubed. You know quadratics are used kind of parabolic shapes. But there are lots of graphs that you don't know what they look like probably without your graphing calculator. So we're going to learn to do that. All right, let's talk just a little bit about this. You've seen this a little bit, but let's kind of review it. Okay. Let's talk about the fact about a function increases on an interval. All right, where it increases on the interval and kind of where it decreases on the interval. All right. So a function increases on an interval if for any two x values like x1 and x2, if x1 is less than x2, if that implies that f of x1 is less than f of x2, then the graph must be increasing or going up. Now look at why that should make sense to you. All right, do you see this graph is going up? And sure enough, look at this point right here. On this point right here, this is your x value and this is your y value. On this point right here, this is your x value and that's your y value. So sure enough, y1 is smaller than y2. x1 is smaller than x2 and y1 is smaller than y2. So as you go to the right, as your x's get bigger, your graph goes up, your y's get bigger. So they're kind of going in the same direction. As you go to the right, you go up. So when x is increased, that implies that y is increased. All right, look what decreasing functions do. A function decreasing on an interval if for any two x values like x1 and x2 in the interval, if x1 is less than f of x2, but f of x sub 1 is bigger than f of x sub 2. So do you see here, in other words, when you move to the right, instead of the graph going up, it's going down. So as your x values get bigger, so your y values come down, they get smaller. So, you know, that's what increasing looks like, and that's what decreasing looks like. Now look at this parabola. Okay, I want you to kind of notice something on the parabola. Okay. I went and just drew some tangent lines. You know, that's where you clip the graph in just one point. So here's a tangent line, there's a tangent line, there's one, and there's one. Now what I say here is notice the slopes. Now do you see that when you look left to right, this line is dropping? So if that line is dropping, what kind of slopes would this one be? In other words, this one's almost straight up, but it's a little bit slanted this way, left to right. Do you remember that those slopes are negative? When your line left to right is dropping, that means your slopes are negative. And look right here. Right here, when you look left to right, the line's going up. So on this side, our slopes, our tangent slopes of our tangent lines here are positive. Now look what happens right here. When it's horizontal, remember, that's when you got a maximum or a minimum. Okay, that's that critical value we were talking about. So remember what slopes of tangent lines are. Slopes of tangent lines are the same thing as the derivatives. And notice this graph right here is going down until you get to here, and then it turns and starts going up. So it's decreasing here, and then it's increasing over here. So where the slopes of the tangent lines, in other words, where the derivatives are negative, your function is going to decrease. And where the slopes of your tangent lines, in other words, where your derivatives are positive, your function is going to increase. Okay, so what we're going to do next is kind of write some steps down, and then we're going to go work about 3 examples. So what I need you to do is kind of pause the video and write this in your notes. So on a test or in class, if I tell you to find where a graph or where a function increases and decreases, the first thing you're going to do is take the derivative. So you're going to take the first derivative. Now, when you finish taking that first derivative, I need to completely factor that derivative. So you break it down until you cannot break it down anymore. All right. Once that derivative is completely factored, I need you to make a split point table. That's what was on that algebra trig review at the very beginning and on test 1. Remember, I told you that you were going to have to be able to do that. So if you don't know how to do a split point table, you need to come see me. And what you're going to do is you're going to put every factor on the same table with its split point. And its split point is where that factor equals 0. And then once you get that factor and its split point on the table, remember, you're going to pick a number smaller and substitute in and write down whether the answer is positive or negative. Then you're going to substitute a number in bigger than your split point, substitute that in and write down whether the answer is positive or negative. You're going to do that for each factor in your first derivative. Then you're going to do what it says and find the final sign. And if the final sign is positive, that's where your function increases. And where the final sign is negative, that's where your function decreases. And so you're going to write down those intervals for increasing and decreasing. And then we're going to talk about, you can also get maximums and minimums off of that table. All right. So you pause this and have this in your notes and have it next to you before we start working these examples. So pause it and get this copied. All right, hopefully you've got that note sitting next to you, so we're going to follow them. Remember what step 1? Step 1 said to take the derivative. Now, on this one, you got several options. Now, I went and did the quotient rule for practice because some of you are still struggling with the quotient rule. But remember what you could do. You could move this up and have x to the negative 2 and then multiply it out. Or you could put x to the 4th over x squared plus 1 over x squared and avoid the quotient rule. So there are a couple of ways to avoid the quotient rule if you don't want to use the quotient rule. All right, I went ahead and used it for practice to remind you. Remember where you start. You start bottom times the derivative of that numerator. So the derivative of x to the 4th plus 1 was 4x cubed minus, then you copy down the numerator, and then you do the derivative of that bottom. So the derivative of x squared is 2x, and all that's over your bottom squared. So this is just your quotient rule. Now, everything after this is algebra, okay? So if you're still having trouble with algebra, you can go to the tutoring center or come see me. So when I first do it, since I'm going to be factoring anyway, I don't want to multiply up and then factor if I don't have to. So I first, after I take the derivative, after I apply that rule, I look and see if there's anything that I can pull out that's the same. So do you see in this numerator, this has an x squared and this has an x, so I can pull out an x. So if I pull an x out, that leaves me this 4x cubed. And if I pull out 1x from x squared, that's still going to leave me 1x. So x times this gives me this. And then minus. If I pull that x out again, that still leaves me this 2, and that still leaves me that x to the 4th plus 1. So I pulled an x out of here, and I pulled an x out of here. All right. Now, I multiplied up what's left. So 4x cubed times x is 4x to the 4th, and I distributed. So a negative 2 times that x to the 4th is a minus 2x to the 4th, and then minus 2 plus 1 is a minus 2. Now, I can clean that up. 4x to the 4th minus 2x to the 4th is 2x to the 4th. And then I noticed I had an x to the 4th here and an x here. So think about it. X to the 4th, you can think about it as x times x cubed. So then I can divide those x's out. Now, you can never go in the middle of like a plus minus and start crossing something out. But you can divide out when you're multiplying things. All right, so those went away and left me 2x to the 4th minus 2 over that x cubed. And I noticed I had a 2 here that I could pull out. So I pulled the 2 out, and that left me the x to the 4th, and then that left me a minus 1. So this is as cleaned up as I could make it. Now, I factored an x out up here, but that's not the only factoring I can do. You should recognize that's a perfect square minus a perfect square. So remember, when you have an a squared minus b squared, that's a minus b times a plus b. So do you understand that x squared is x to the 4th minus 1 squared is 1. So I've got the difference of perfect squares. So my a, so to speak, is x squared and my b is 1. So I did a first minus a second, and then that first one plus that second. Well, then this is another difference of perfect squares. So this one factors into x minus 1 times x plus 1. So see, I had a lot of factoring to do. Okay, so I've got 1, 2, 3, 4, 5 factors. So all 5 factors have to go on this table. Now, I only did them one at the time. The first thing I did was, doesn't matter which one, I got to put them on this. So the first thing I did was just write down a 2. And then I went way down there and drew a number line. Okay. Now remember what a split point is. A split point is where that factor equals 2. I mean, where that factor equals 0. Now, is 2 ever going to equal 0? That means a 2 doesn't have a split point. So that means it's either positive all the way across or negative all the way across. Isn't a positive 2 always positive? So I would just write down a bunch of positives. Okay. So that's why there's a 2 and there's pluses all the way across. Then I'd go to my next factor, x minus 1, and I would write it down. X minus 1. Now I'm going to go do its split point. Now what's its split point? Remember what I said its split point is? A split point is where that factor equals 0. So when does x minus 1 equal 0? If you solve that, you get x to be 1. So somewhere on this number line, there's a 1. Okay. And I went up here and picked a number smaller than 1. What's a number smaller than 1? Like 0. We'll see 0 minus 1 is a negative 1, and that's negative. Pick a number bigger than 1, like 2 or 3 or 10. 3 minus 1 is 2, and that's positive. So I have a bunch of positives. So that's what I did right here. I wrote down x minus 1. I went over here. My split point was 1, and that's why there's negatives, and then it turns positive. Okay, so I did that for every factor. I went and wrote down x plus 1. Now, when is x plus 1 equal to 0? Well, it's equal to 0 when x is a negative 1. So that's why I have this red negative 1 here. And I color coded it so that you could see every number with its split point. So x minus 1's that aqua blue, and its split point's in aqua blue. X plus 1's in red, so its split point's in red. Now, what about x squared plus 1? Now, think about it. What is that split point? When is x squared plus 1 going to equal 0? Well, I'd have to subtract 1 from both sides, wouldn't I? Which would say x squared then, for that to be true, x squared would have to equal a negative 1. Now, when is a squared number ever going to be negative? It's not. So there's no answer to this. So that means there's no split point. Just like this 2 up here didn't have a split point. So that means that this factor right here is either positive all the way across or negative all the way across. How do I know? Substitute in any number. What if you substitute in 0? 0 squared is 0 plus 1 is 1. 1 is positive all the way across. If you plugged in the negative 1, negative 1 squared is positive 1. Positive 1 plus 1 is 2. 2 is positive all the way across. So when it's either always positive or always negative, just plug in one number and see what it is. All right, when is x cubed equal to 0? Well, it's equal to 0 when x is 0. So this 0 right here is the split point for this factor. So I plugged in a number smaller, like a negative 1. When you cube a negative 1, it's negative. Pick a number bigger than 0, like 1. Well, 1 cubed is 1, and it's positive. So I did them one at the time. Does everybody understand? I did them one at the time. I wrote down a factor, wrote down its split point, drew that line, picked a number smaller, and plugged it in only that one. So you only plug in 2 numbers in every factor to see whether to write down as positive or negative. Now, when you get them all on the table, do what it says. All right. All this means multiply. So I got to multiply these 4 and then divide by that one. Okay. What's a positive times a negative? It's a negative. What's that negative answer times that negative? That's going to be a positive. What's a positive times a positive? It's a positive. Now, so I multiplied all 4 of those and ended up being positive. But what's a positive divided by a negative? It's negative. We'll see a positive times a negative times a positive times a positive. So when I multiply those 4 things up, it's negative. but then that negative divided by that negative would be positive. So I'm doing exactly what it says. I'm multiplying this sign times that sign times that sign times that sign, and then dividing by that one. So when I multiply these four up and get a negative and divide by that positive, it stays negative. When everything's positive and you multiply and dividing, it's positive. So I circled my final signs. Remember what it says back here. Where the final sign is positive, your function's increasing. See, the final sign's positive between -1 and 0. So it's an increase between -1 and 0. It's also positive when it's bigger than 1. So from 1 up, from 1 to infinity, this thing's going to increase. It decreases where the final sign is negative. So the final sign's negative right there. So from negative infinity until I get to -1, it's going to decrease, and then it's going to decrease between 0 and 1. So where your final answer is positive, it increases. Where your final answer is negative, it decreases. Now, how do I get maximums and minimums off of it? Well, use common sense. Now think about it. This graph right here is going to go down, and then it's going to turn and go up. If you got a graph that's coming down and it turns and goes up, what are you going to have right at that turn? Aren't you going to have a minimum? So I've got a relative minimum at -1 comma something. Now I'll tell you how I knew that was a 2 in a minute. But first, I just had -1 comma something. I mean, I just knew it was -1 comma something. Now look what happened. The graph is going to go up, and then it's going to turn and go down. So when something's going up and it turns and goes down, what are you going to have at that turn? Well, if something's going to go up and it's going to turn right here and go down, what are you going to have right at that turn? Aren't you going to have a max? Well, you would think you would. So I probably wrote down to start with 0 comma something. I'll show you why I had to fix that in a minute. All right. Then I'm down here, it's coming down again because it's negative. It's going to turn and go up. So again, if it's coming down and it turns and goes up, what are you going to have right there? Well, see, you would have a minimum. So I've got a minimum at 1 comma something. Now, how do I get the y parts? I plug these into my original, not into my derivative, into my original. So if I plug a 1 in there, 1 to the 4th is 1, 1 plus 1 is 2. So I've got 1, all right, to the 4th, and then plus 1, because it says plus 1 right there. And then the whole thing is over that 1 squared. All right. So look what happened. All right. Because I wasn't paying attention. That's going to be, look what's going to happen. I'm going to have 1 to the 4th is 1. 1 plus 1 is 2. So that's a 2. Over. And then 1 squared is 1. Well, what's 2 divided by 1? 2. So that's how I know to put a 2 right there. What if instead it was -1? What if that was negative and this one was a -1? Well, but what's a -1 squared? Well, it's still a +1. What's a -1 to the 4th? Well, it's still a +1 plus 1 is 2. So even when I plug a -1 in, I get a 2. So that's why there's a 2 there. So that's how I knew to go back here and put down a 2 and a 2. But look what happens when I plug 0 in there. I'm going to have 0 to the 4th plus 1. And it's going to be over 0 squared. Now, what's going to happen? I'm going to get a 1 over a 0. What's that mean? Remember, you can't have a 0 on the bottom of a fraction. That means that's undefined. There's no point there. So then they'd have to go erase that one. So that's why I had to write down none. Now, that's the reason. Make sure we're clear. Let me go back and make sure that you understand what I said up here. Look what it says. It says minimums and maximums occur potentially where those change. Where what changes? Where the increasing and decreasing changes. So see right here, the function changed from decreasing to increasing. So that's a candidate for a max or min. Right here, it changed from increasing to decreasing. That's a candidate for a max or a min. And again, a candidate. How do you know whether it's really a max or min? You plug in the X values. If you get points, they really are maxes and mins. But if you don't get points, they're not. And we're going to talk about later. I'm probably going to have an asymptote right there. We'll figure that out later. Okay, so let's go work another one and make sure we're still good. Remember, our first step is we take the derivative. So I've got that extended power rule on this one because I got no idea what a graph to the 2/3 looks like. So that 2/3 comes down, my expression stays the same, my power goes down by 1. 2/3 minus 1 minus 3/3 is negative 1/3. Then remember, you got to do the derivative of the inside, so you got to do that 2x. All right, now I can't factor anything out, so I'll just clean it up. So 2/3 times 2x. Well, you know, this is like I've got something over 1. Let's make sure we're clear. You know, that's like over 1. Well, see, that's 2/3 times 2x gave me 4/3 x. And then there's that x squared minus 4 to the negative 1/3. But remember, we don't like negative exponents, so I moved it to the bottom. So remember, that's like an x over a 1. And that's like that's over a 1. So I've got a 4 and an x on the top. I got a 3 on the bottom, and I moved that thing to the bottom. So the negative 1/3 turned into a positive 1/3. So that's as cleaned up as I could get it. Then I want to make sure that I factor it completely. Well, I notice again, that's the difference of perfect squares. So that factors into x minus 2 and x plus 2. But remember, this thing is to the 1/3 power. And that 1/3 goes with everything inside that parenthesis. So that 1/3 goes with that x minus 2, and that 1/3 goes with that x plus 2. Now, you can stop right here. It's just, I know I'm going to be plugging some things in, and I do better plugging into roots. So that's why I changed that 1/3 power to cube roots. So I've got 1, 2, 3, 4 factors. So I put my 4x on the graph. Remember, there was nothing there to start with. I had a 4x. And then I drew a line down there. And then I wrote down its split point. So when does 4x equal 0? Well, 4x equals 0. And I solved that. So I divided both sides by 4, which said x was 0. So 0 is the split point for 4x. So I've got the factor, and I put its split point 0. Okay. And then I picked a number smaller. What's a number smaller than 0? Like maybe negative 1. So 4 times a negative 1 would be a negative 4. Pick a number bigger than 0, like 1. Well, 4 times 1 is 4, and that's a positive. So does everybody understand what I'm doing? I'm doing one factor and one split point. So originally all I had was 4x and the 0. Then I wrote down my next factor, 3. Well, when does 3 equal 0? Well, 3 is never going to equal 0. So it's going to have a split point. It's either always positive or always negative, and 3 is always positive. Well, then I went and did the cube root of x minus 2 is 0. Now, how do I get rid of that cube root? All right, wouldn't you have to cube both sides? So I cube that side, and I cube this side. What happens when you cube a cube root? Doesn't it go away? And that left me x minus 2. And what happens when you cube 0? Don't you just get 0? Okay. And then I added 2 to both sides and got x to be 2. So I went over here and I wrote down my factor, cube root of x minus 2, and I wrote down its split point 2, and I drew that line. Then I picked a number smaller than 2, like 0. All right, what's 0 minus 2? It's a negative 2. And the cube root of a negative is negative. All right, if you put down a negative 6, a negative 6 minus 2 would be a negative 8, and the cube root of a negative 8 is a negative 2. If I put a number in bigger than 2, like 3, well, 3 minus 2 is 1, and the cube root of 1 is 1, and that's positive. So all I'm doing is writing a split point down with its factor and putting a number in smaller and bigger. And I did the same thing on this one. I set that one equal to zero, cube both sides and got a -2 for this one. So there's my factor, here's my split point. I picked a number smaller and got a negative answer, picked a number bigger and got a positive answer. So once I get all those factors and split points on my table, then I do what it says. So I multiply these three and then divide those. Okay, so do we understand that a negative times a negative is a positive and a positive times a positive is a positive? And then this negative divided by this positive would be a negative. If I multiply and divide these, I'm going to get all positive answer. When I've got one positive, it's positive. When everything's positive, negative. When everything's positive, it's positive. So they're my final signs. Where the final signs are positive, it's increasing. So it's increasing between -2 and 0 and increasing from 2 up. It's decreasing until you get to -2, so -infinity to -2, and it's decreasing between 0 and 2. All right. Now think about it. It's coming down and it turns and goes up. If it's decreasing and it turns and increases, what are you going to have at that turn? Aren't you going to have a relative minimum? So I had a relative minimum at, not a relative. Let's see what I got. I need a relative. Let's try this again. I wrote it down wrong. I need a relative minimum right there, not a relative maximum. Okay. So I've got a relative minimum right there. Okay. Get that off. So then the same thing, now it's going up and it turns and goes down. I'd have a maximum right here. So fix that in your notes. I wrote that down backwards. I wasn't paying attention. Okay. Because if you're going up and then you turn and go down, right at that turn, wouldn't you have a max? So I got a max at 0. And again, I'm coming down, and if I turn and go up, then I'd have to have a minimum right here. Now, how did I get these y coordinates? I plugged into my original. All right, if I plug a 2 in there, 2 squared is 4. 4 minus 4 is 0. 0 to any power is 0. But now when I plugged in this 0, I had 4. I had a -4. To the 2/3. Now, what in the world does that mean? All right. So that means that I had the cube root of a -4 squared. Remember that bottom number is your index number and that numerator is your power on your radicand. Put that in a parenthesis. Well, what's a -4 squared? It's 16. So that's how I got the cube root of 16 right there. Okay. Let's go work a trig one because we all tend to panic when we see trig. Okay. Now trig's a little different. Sometimes with trig, you don't get a bunch of factors. So look at this one. Here's my original, 1/2 x minus sine x. And it tells you just to go from 0 to 2 pi so that you don't just keep going and going and going. All right, so I'm going to start at 0 and end at 360 degrees. So I took the derivative and got 1/2 minus cosine x. Now, I can't clean that up and I can't factor it. So I've only got one factor for this table. So I wrote down my one factor, but then I had to find its split points. Remember how I find the split points? I find the split points by setting that factor equal to 0. So I added cosine to both sides. Now, I had to figure out what x was. Well, how do I do that? The x is an angle. The cosine of some angles 1/2. So I went and drew it. So cosine, remember, is adjacent over hypotenuse. So my adjacent side must be 1. My hypotenuse must be 2. I used Pythagorean theorem to get that square root of 3. So I drew this triangle so I could figure out what that angle was. Now, think about it. That should pop in your head. Oh, I recognize that triangle. That's a 30-60. But you have to remember what's across from the square root of 3. That's a 60-degree angle. Now, this answer right here, cosine of some angles positive. In what quadrants is cosine positive? Doesn't cosine depend on your x value? So where's your x value? Think about your axes. Where is your x value positive? Well, you have to go to the right. So that's quadrant 1 and quadrant 4. So that's how I knew I had a quadrant 1 and a quadrant 4. I got 2 split points. So with trig, sometimes you get more than 1 split point. Now, you can't write down 60 degrees because you have to have radians. So you had to change it to pi over 3. So remember that little formula you memorized way back at the beginning of the semester. Your reference angle is 360 minus your given angle. Okay? So here's what I knew. I knew that my reference angle was 60 because that's my quadrant 1 angle. And I knew that that was 360 minus something. I'm going to put x there. And then I solve for x. So if I move that x over here, it becomes positive. If I move that 60 over here, I get a minus 60. I really subtracted 60 from both sides. So my quadrant 4 angle is 300. Now, luckily, like we talked about before, that's going to be some multiple of your reference angle. So something times 60 gives me 300. So I can take my calculator and divide it and figure out that 300 divided by 60 is 5. So that's got to be a 5 right there. And then remember, 60 was pi over 3. So that's how I figured out my other split point was 5 pi over 3. So I have my 2 split points down here. And I have to pick a number to the left and a number to the right. So you can have a scientific calculator. All right, just think about a number that's smaller than 60 degrees. All right, like maybe 30 degrees. Okay, if you type in the cosine of 30 degrees, all right, remember 30 is up here. So that would be the square root of 3 over 2. So on your calculator, if you type in the cosine of pi over 3 or the cosine of 30 degrees, you get like a 0.8. So if you take the square root of 3, if I take my calculator, all right, and I do the square root of 3 divided by 2, and I say 1/2 minus that number, the answer is negative. All right, think of an easy number between 60 and 90 and 300. Wouldn't 90 be a number? 90 degrees? All right, remember 90 degrees is up here. Okay. So remember that's the point 0, 1 on your unit circle. So, you know, at 90 degrees, your cosine would be 0 and 1/2 minus 0 is 1/2, and that's positive, but you got your scientific calculator. If you pick another number between 300 and 360 and find the cosine of that, like 310, and say 1/2 minus that, you're going to get negative. So this thing increases between pi over 3 and 5 pi over 3, and it's negative. The final sign is negative here and here. So it said just go to 0 to 2 pi, so that's why I don't have negative infinity to that. All right. So now I know where my function increases and decreases. Now, how do I get these answers right here? I'm going to have to go up here and plug them in my original. So I'm going to have to take my scientific calculator and say 1/2 times, and I'm going to put pi over 3, you know, like about 3.14, 3 1400ths. And then minus the sine of pi over 3. So I put all that in my little scientific calculator. And when I did, I rounded off, and I think I ended up getting about a negative 0.3 when I did that. And I put 5 pi over 3 here, you know, then I went back and did by 5 pi over 3 for my x here and here. When I did that one, I think I got about 3.5. So about a 3.5. Okay, not 35. Let's make sure I'm at 3.5. Okay, So there are examples, some more examples in your book. So I'll go look at them. But what you're going to end up doing on all of these, increasing and decreasing, I kind of did harder ones. Your homework's going to be a little bit easier probably. Remember what you do. You take the derivative, you clean it up, then you completely factor it. Then you take one factor and put it up here with a split point and put in a number smaller and bigger, right, and whether the answer is positive or negative. Then you go to your second factor and you write it down on that same table. Find its split point on the number line. Pick one number smaller than that split point and one number bigger, right down whether it's positive or negative. When you get them all on the table, you multiply and divide them. Where the final sign is positive, the function increases. Where the final sign is negative, it decreases. Then if something's increasing and it turns and decreases, if it's going up and it turns and goes down, you know, you got a relative max potentially there. All right. If it's coming down and it goes up at that turn, you'd have a potentially have a relative minimum. And the way you decide if you have those and get those y values is you plug those x coordinates into the original. If you get a point, good. If you don't get a point, then you don't have a max or min there. You erase that. All right. So go try your homework and let me know if you have any trouble.